Hi there, this is Billy. This is part one of my multi-part video to show you how you can create a vertical grow tower that is passive without pumps, is completely silent, and you can grow vegetables and fruits indoor. It has its own grow lights, so even if you don't have sunshine or you don't grow by the window, it should be all fine. So keep on watching. This will be part one that shows you the 3D printing design and how to print it. And then I'll follow with part two where I install the modules step by step. I want to take some time to show you my 3D design for the 3D printed vertical passive hydroponic system. So this is how it looks after it's stacked up. The top of the tower is the LED holder. So you can see the PVC pipes, 25 millimeter and the 20 millimeter. They can slide in and out to adjust the distance. And then there's some more PVC pipe to connect to this LED grow lights, 4 feet, 18 volts, full spectrum white color. Is hanging down from the LED holder, which is also the cover for the nutrient tank. So the second one is the nutrient tank. And let's just zoom in to the top of the tank. So this is the nutrient tank. There's a stem pipe and a small hole here where we'll connect the central pipe. And then there's a separated tunnel here that opens up to the nutrient tank. So we will fill by taking off these green lids. Let me take out the lids. Okay, so you can see inside now without the lids. And then there's the water level indicator. You just power water in. Water level indicator will rise and fall according to the water level in the nutrient tank. So you power nutrient solution into the tank. Okay, so this is the nutrient tank. And then this small hole here will connect the central pipe, a 10 millimeter diameter rubber duct. We'll connect it to the growth tank. So it will connect the thick rubber pipe down to this 3 growth tank, and each growth tank will be used to plant different the same type of plants that need the same EC value. For example, vegetable 1.5 or fruits is 2.5, something like that. There's a stem pipe inside to allow the central pipe to pass through. Also, there's a electric cable for the LED grow light to pass through all the way to the bottom. As it passes through, we will take a branched rubber pipe from the main pipe and then connect to a flow valve. Function of the flow valve is to make sure the water level, nutrient level is controlled at around 1 inch. Rubber pipe will connect to the flow valve and the nutrient will come out of the flow valve, and the flow valve will stop nutrient flow after 1 inch. So we were at this top 3 growth tank, right? And then there is a door, maintenance door. So I have it printed in one piece. So after you finish printing, you have to use the scissor or knife to cut through and open up the door. So it should be easy to cut through and open up the door. There's a hinge inside, and then there's a small lock. You can press and pull and open the door. So you have the same door at both sides of the tank, so you can have 2-hand operation. Sometimes you need one hand to hold the pipe, another hand to hold the valve to be able to fix it. So if you go down, there's the second nutrient tank. The second nutrient tank allows us to put in a nutrient of different EC value. For example, If your top tank is for the vegetable, EC 1.5, the second tank at the middle, you can put in nutrient solution of 2.5 EC, EC value of 2.5, so you can use it for fruits. In that way, you can separate the tower into two halves, the top half for the vegetable, the bottom half for the fruit. Then they can get the right composition of nutrient. Otherwise, if you fit the same type of nutrient for fruit and for vegetable, you have to balance between one another, and it may not be the best for either. So it's better to separate them into two groups and feed by two different nutrient tanks. And the base is important because we need to lock down the base to a board that is heavy and big, so you can stand this tower and it will not fall down easily when someone pull it or there's a wind blowing. Okay, if you take a look at the base tank, it has a smaller tank and a bigger tank. The inner tank is to collect any flooding of nutrient or accidental spill of nutrient solution when we power the nutrient will be collected at the base tank. So it will protect your floor, it will not wet your floor. And then the outer tank is to collect water that may come out of the plant itself or accidental spills of the nutrient. If you can, it may be even better to have a plastic box to be the base, so you can collect more spilled nutrient and further protect your floor, your carpet. But this is what works for me. So that's the whole system. So this is another design I have. This one, the pipes are gone. They are pushed inside. So the pipes are pushed inside the tank. And you can use the 32mm grow basket to put it here. I'll design it to fit the rim of the basket as well. So you don't need to cut the basket in any way, just push it in. It will secure properly. There will be enough depth, 35mm for this growth basket. So this one is improvement on the outlook because you don't see pipes extruding out from the tower. It's all inside. And it will be very nice. You just see the plants extruding outside but not the pipes. And let me show you how you can print each one. So if you want to print the nutrient tank, for example, this one, okay, then you can go to Fusion 360. I will create the STL file for each one of these. But I just want to show you how to print it. Okay, then you highlight the base tank, the nutrient tank, this one, and then it will turn blue. And then it will start Cura. Cura will be started, and you can adjust some setting. Okay, so by default, usually the 3D printer is set up with layer height of 0.2mm, and your nozzle is 0.4mm. So if you print like this, it will take a lot of time to print. Let me show you. Let's do the slicing and see how long it will need to print. I think it will need you almost 2 days to print one tank. Okay, you see 2 days, 6 hours. So you can reduce it by printing with a layer height of 0.3 millimeter. See what happens. I'm using the Creality Ender 3 Pro to print, which has the print bed value of only 220 millimeter times 220 millimeters times 250 millimeters. Okay, now we improve to 1 day 14 hours, close to 1 day 15 hours actually. And if this is not good enough for you, then the next thing you can do is change your nozzle. You can physically change your nozzle at the 3D printer's hot end. If you're not familiar with that, you can watch some YouTube video how to physically change that. You need to buy some bigger nozzles, such as 0.6 millimeter, or you can make it 0.8 millimeter. Okay, let's see, if you make it 0.8 millimeter, you can print a layer height of 0.6 millimeter and see how much that can save us. Okay, now we reduce the print time to 15 hours, 15 and a half hours roughly. Okay, but I tried this before. There is a penalty. The penalty is that the tank printed this way will have a lot of small holes between the layers, and it will end up leaking water. And then, however, you can still fix it by spray painting the tank with some paint. Not just one layer, maybe 3 layers of paint. Then you can cover those small holes, and then you can still use it. However, the paint is not good for health, so there's a trade-off. You need to find a paint that is good for health. Okay, so if we do not go that extreme, we go to 0.6 millimeter. Let's see what happens. We change the nozzle to 0.6 millimeter. Okay, and then we change the layer height to 0.4 millimeter. Let's see what happens. Okay, it's 1 day 4 hours. 1 day 4 hours, which is not bad. I think this is the middle ground. It may still leak depending on the material. I've printed on different materials, some leak, some will not leak. So you need to try it out and check it out. Or you need to use the paint to fill in the gaps. So if you use paint, just paint the outside, don't paint the inside, because the inside will be touching the nutrient solution and it will create chemical reaction that will either melt the paint or do bad to the plant and to yourself as well. So if there's anyone out there who have a solution to this, a balance between the printing time and the water leakage, please leave the comment or on Facebook or on YouTube for me so I can improve it going forward. So I've been printing using the 0.4 millimeter nozzle and the layer height of 0.3 millimeter. And this way it will definitely will not leak. So this is the safest setup, but it does require a long printing, more than 1 day. 1.5 days actually. If you don't want to use the paint, this is the safest printing setup. One more thing, because we are printing occupying the whole print bed area, so we need to remove the support. Okay, by removing the support, I mean here, usually you will print a ring outside your object to print, and then print the object, right? That is called a skirt. There's no space to print the skirt, so we can't check the skirt button or the brim or the wrap. So you have to select none. No support on the print bed. The print bed support will be none. Otherwise, you will not be able to print this thing. Okay, that's important. And then the other support will also be none. There's no support required. The infill, it can be 20%, 40%, up to you, because the wall is very thin. There's not much infill. You need to make sure after printing you test the leakage. See whether the tank holds the water and don't leak. Try it out before you print all the tanks, otherwise you'll be wasting your time and material. And when you choose the color of the print material, try to choose with the dark color, brown or coffee color or black. Don't use white or yellow or orange, because they cannot block the lights, and then you will have algae growing all over your growth tank, which is very bad for the plants. Okay, so this is how you print it. There are many different models you need to print. I will update the fingerless site with all the print models. So you have the growth tank. Let me show you how long you need to print your growth tank. The nutrient tank is the biggest model, and then the growth tank is the second bigger. Okay, so this is the growth tank. I have another version that has 6 plant insert pipes, and where the plant insert pipes are lower, so it's good for planting vegetable. This 4 pipe model is good for planting fruits or plants that have a bigger roots, because it's higher above the bottom, so you have more space for the fruits. And let me see how long does this take. Okay, this is 1 day, 11 hours. Let me test the next one. The next one I'm going to test is the base tank. Let me try to clean the base tank. So these models are connected together through some notches. You can push it in and twist and lock it down. So it's easy to stack it up as high as you want. You can start with a 3 tank unit, 1 nutrient tank, 2 growth tank. So this is our base. So this hole is for the electric wire to come out. So this is the base tank. This is the hole where the electric cable for the LED grow light will pass through. And let's see how long it will take to clean it. This is the flow valve. You have the box, you have the valve that floats, And then you have the base where you stick onto the growth tank. So let me show you one by one. Okay, this is the mount, and then this is the valve. It's empty on one side, so it can float. And then this is the box. Okay, you can clean them one by one. Clean the box first. Okay. So cleaning the flow valve, we should go back to the layer height of 0.2 millimeter to avoid leakage, because the flow valve, you can't have leakage in the flow valve, otherwise it will not float. So we should go back to 0.2 millimeter layer height. And this one takes 3 hours to print. I've captured the screens from Cura on the time taken to clean each compartment, the tanks, flow valve. This is the growth tank with the inner pipes. This is the growth tank with the outer pipes. This one has the inner pipes, but 6 of them. And this one has the 6 outer pipes. This one has the 6 outer pipes. And this is the cap at the top to hold the LED grow lights. This is the power cover, power block on the grow lights. This is the lid of the nutrient tank. And this is the nutrient tank. This is the whole tower again. Thanks for watching. This is part 1 of the video. Please follow on to the part 2, where I'll show you how to physically install the printer modules and the other steps like connecting the grow light to the top of the tower. Thanks a lot.